All right, everybody, this is a guided walkthrough for day 5 of the Advent of Cyber event for 2025 over at TryHackMe.com. This room is called IDOR, Santa's Little IDOR. So after you join the room, this is what you do. So you just go down to task number 1, and we've got a story to read about. So let's go ahead and do that. Okay, the story. The elves of Wareville are on high alert since McSkitty went missing. Recently, the support team have been receiving many calls from parents who can't activate vouchers on the Try Present Me website. They also mentioned that they are receiving many targeted phishing emails containing information that is not public. The support team is wary and has enlisted the help of the TBFC staff. When looking into this particular case, they discovered a suspiciously named account named Sir Carrotbane, which has many vouchers assigned to it. For now, they have deleted the account and retrieved the vouchers, but something is going on. Can you help the TBFC staff investigate the Try Present Me website and fix the vulnerabilities? Learning objectives. What are we doing today? Understand the concept of authentication and authorization. Learn how to spot potential opportunities for insecure direct object references, otherwise known as IDORs. Abuse IDOR to perform horizontal privilege escalation, and learn how to turn IDOR into SDOR, Secure Direct Object Reference. Okay, so to start the exercise, we need to take a look at the connection card here. Do I need to start the attack box today? Yes. Do I need to start a VM today? Yes. So we're just going to go down, and we're going to start up both our attack box and the vulnerable machine. So click on Start Machine, and then click on Start Attack Box. So the attack box is going to take a couple of minutes to initialize, but while it's initializing, we're going to talk about what's going on in this room. Okay, so answer the question below. My target machine and attack box have started, and I'm ready to learn about IDOR. Done. Okay, so task number 2. IDOR on the shelf. It's dangerously obvious, really. Okay, have you ever seen a link that looks like this? So https awesomewebsite.thm track package ID equals 1001. When you saw a link like this, have you ever wondered what would happen if you simply changed the package ID to 11 or 12? In its simplest form, this can be a potential case for IDOR. IDOR stands for Insecure Direct Object Reference and is a type of access control vulnerability. Web applications often use references to determine what data to return when you make a request. However, if the web server doesn't perform checks to ensure that you are allowed to view the data before sending it, it can lead to serious sensitive information disclosure. A good question to ask then is, why does this happen so often? We need to understand references and web development a bit more to answer this. Let's take a look at what a table storing these package numbers from our link example would look like. Okay, so we got package ID, person, address, and status. So this is an example of a table which would be handled by a SQL system, for example. So package ID 101 is for Alice Smith. It is delivered. Package ID 1002 is for Bob Johnson and is in transit, etc., etc. So if the user wants to know the status of their package and makes a web request, the simplest method is to allow the user to supply their package ID. We will recover data from the database using the simplest SQL query of select person, address, status from packages where package ID equals value. Okay, and we'll just take a look at this for a second before we actually take a look at the attack box. Okay, since package ID is a sequential number, it becomes pretty obvious to guess the package IDs of other customers. And since the web application isn't verifying that the person making the request is the same person as the one who owns the package, an IDOR vulnerability appears, allowing attackers to recover the details for packages belonging to other users. Even worse is when a feature like this doesn't require the user to authenticate. then there would be no way to even tell who is making the request. To dive a bit deeper, we need to understand authentication, authorization, and privilege escalation. Okay, let's see. I am not a fan of the vulnerability name IDOR. I prefer the name authorization bypass. If you want to understand my reasoning, expand here. Otherwise, you don't need to be bored with the details. Okay, wait, can we not? Okay, yeah. I prefer to do a little less reading if I can. Identify identify identity defines our reach. To understand the root cause of IDOR, it is important to understand the basic principles of authentication and authorization. Authentication is the process by which you verify who you are. For example, supplying your username and password. Authorization is the process by which the web application verifies your permissions. For example, are you allowed to visit the admin page of the web application, or are you allowed to make a payment using a specific account? You may think that authentication only happens once when you supply your username and password, but that is actually not the case. After providing your credentials, you receive a cookie or token called session information. Each subsequent request you make to the application includes the session information, which is verified by the application. This initial verification process is still authentication and happens for each request. This is why websites will often redirect you back to the login page. It means your session information is expired, and thus you need to re-authenticate with your credentials to receive new session information. Authorization cannot happen before authentication. If the application doesn't know who you are, it cannot verify what your permissions are. This is very important to remember. If your IDOR doesn't require you to authenticate, such as in our package tracking example, we will have to fix authentication first before we can fix the authorization issue of making sure that users can only get information about packages that they own. The last bit of theory to cover is privilege escalation types. There's vertical privilege escalation, which is where you gain access to more features. For example, you may be a normal user on the application, but you can perform actions that should be restricted to administrator. There's also horizontal privilege escalation. This refers to privilege escalation where you use a feature that you're authorized to use, but gain access to data that you're not allowed to access. For example, you should only be able to see your accounts, not somebody else's accounts. IDOR is usually a form of horizontal privilege escalation. You are allowed to make use of the track package functionality, but you should be restricted to only performing the tracking actions for packages that you own. Now that we understand the theory, let's look at how to abuse IDOR practically. So we've got iterate digits, observe responses. We'll start with the simplest example of IDOR. On the web application, let's authenticate to the application using the details below. So we got username Nils. Let me copy that. And we got password TryHackMe 2025. And we got an IP address or website. I'm going to copy this. And I'm going to try logging in. Just a second. So to do this, we need to get access to our attack box. And in the attack box, I'm going to make this full screen because the web application in this case, it's not very fun to look at, especially if it's cramped up. So I'm going to view this in full screen. Then we're going to paste in the IP address here. Then we're going to open up the web browser. Why does it look like this? Okay, so after a few seconds, our attack box web browser will open up, and then we can access the web application with the IDOR vulnerability. Okay, so just paste in the resolution on this thing isn't super good, but this is the website over here. So try present me, and we need to put in our username and password. So the username is NIELS, and the password is TryHackMe number 2025, and then click on Login. Okay. So over here we've got the account information for this user over here, and the good thing is that we don't need to do a lot of reading on this web page, and we'll talk about why that is. Okay, where are we now? Over here. Once authenticated, you should see a dashboard like this. So we see the dashboard. Let's start by using the developer tools in our browser to better understand what is happening in the background. Right-click on the page and click Inspect, and then click on the Network tab as shown below. Okay, so we're just going to go over to the web page here. Let me reload the page. Okay, and then we can take a look at the web developer tools. So web developer tools, you can click on this button here, and then you can scroll down a bit, and we go to more tools, and then web developer tools. We can also use the keyboard shortcut Control-Shift-I. What they want us to do is they want us to take a look at the network tab. So inside of here, click on the network tab, and they want us to reload the page. So after that, reload the web page. And we see a lot of different web pages, well, a lot of different resources are loaded in. Okay, we'll talk about this. Refresh the page and see what requests are being made. It should look like something like this. Okay. Okay, so here in the web browser, we do full screen F11. That's a little better. It still doesn't look super great, but it's a little better. Okay, so we see here a bunch of resources that have been loaded in, like view account user ID equals 10. View account ID user equals 10. That tells me that we might have an IDOR situation here, because we can change this user ID number from 10 to whatever number we want. We'll talk about how we do that in just a sec. So let's take a look at the view account info request. Click on it and you will see the following. So we got user ID equals 10. In the above image, we see that user ID with the value of 10 was used for the request. If we click and expand on the responses tab, we can see that this user ID corresponds to our user. So response user ID for our user, nils. And yeah, so we can go over to the web app here, and we'll click on this, and we'll take a look at the request. No, we'll take a look at the response. So in the response, we get a bunch of JSON information with our user account information. So username, email, first name, last name. And so this is our user's information, and it's got a user ID of 10. If we're able to access the server, but give it a different user ID, we may be able to access other users' information, which would be not a great thing from a security standpoint. Okay, this tells us that the application is using our user ID as a reference for getting details. So let's see what happens when we change this. In the developer tools, navigate to the storage tab and expand the local storage dropdown on the left side and click on the URL inside of it. So this is referencing storage. So over in the web application, in the web developer tools here, we're going to go over to the storage. So there's a bunch of tabs in here. Click on storage, then click on the local storage here. So we've got local storage for this website. Click on that. And we see that we've got a couple of items. We got our authorization token. So this is basically our session token that we use for this website. This lets us, this keeps us logged into the website. We also have this other cookie, which is called auth user. And this defines what type of information we're supposed to be looking at. So we can actually go in here and we can start messing around with the number. So 10 is our user number, but what if we look at 11? So we change that out and then we reload the page. Oh, I reloaded the entire thing. Wow, I didn't mean to do that. Okay, so let's use the keyboard shortcut Control F5. So now we're not the nils user, we're instead the test user, so test@test.com. So we can change this again to look at other users' info. So let's take a look at user 12. So plug in user ID 12 and then reload the page. Okay, now we're test@test.com. Let's try that one more time. So we'll change the user ID to 13 and then we'll reload the page again. Okay, now we're the bunny@badbunny.thm user. So obviously this is a vulnerability because we can see other user information. So we can see their vouchers, we can see which vouchers they have available to them for gifts. We can see the ones that they've used already. And if they have any children that they added to the system, we would see who their children are. So yeah, really bad stuff. So change the user ID to 11. Yeah. So in disguise, obvious references. Sometimes IDOR might not be as simple as a number. In certain cases, encoding may have been used. On the loaded profile, click on the eye icon next to the first child as shown in the image below. Okay, I think we need to go back to our original account for this. So we'll change our user ID to 10 again, and we'll reload the page. Okay, so we got children. We got Bilbo over here. We can click on the I, parent information, parent ID 10. Okay, so we got a bunch of potentially abusable stuff. Okay, now go back to the network tab and take a look at the requests being made. You should see a request like this. So you should see something like this, get something something. It's been base 64 encoded. That's funny. Okay, let's confirm this. So in the application, go to network. Oh, this is so hard to look at. Okay, so we saw something like this. So this so child ID 2, first name equals Bilbo, parent ID equals 10. We can manipulate this. We could probably manipulate this and look at other people's children, which sounds really bad, but you know, we're not actually looking at children, we're looking at data. Anyways. So simply put, mg equals equals is just the base 64 encoded version of the number 2. You could still perform IDOR using this request, but you would need to base 64 encode the number first. But in digest, the objects remain. So encoding isn't the only thing that you can use to hide potential IDOR vulnerabilities. Sometimes the values may look like a hash, such as MD5 or SHA-1. If you want to see what that would look like, take a look at the request that happens when you click on the edit icon next to a child. So the edit icon, let's do that. So let's go over to the edit icon. So edit, click on edit. Okay, so I think we're trying to pay attention to this right here. So this MD5 hash. No, we're supposed to pay attention to this other thing. What's the other thing? This right here. Okay, child ID number, and this looks like a hash. So it's probably something like an MD5 hash. This value, we're talking about this value right here. Oops. Let me go back. Sorry, but I need to reload this page. Oh, okay. So we're now looking at, okay. So it just opened this up. Okay. So while the string may look random, upon further investigation, you can see this is a type of hash. If we understand what value is used to generate the hash, we can perform an IDOR attack by simply replicating the hashing function. Using something like hash identifier can help you quickly understand which hashing algorithm is being used and can often tell you what data is hashed. Okay, so we're just going to skip this section. It's deterministic, obviously reproducible. Sometimes you need to dig quite deep for IDOR. Sometimes IDOR is not as clear. Sometimes the IDOR stems from the actual algorithm being used. In this last case, let's take a look at our vouchers. While the values may look random, we need to investigate what algorithm was used to generate them. Their format looks like UUID. So let's use a website such as the UUID decoder to try to understand what UUID format is being used. So copy one of the vouchers to the website for decoding, and you should see something like this. So we're talking about the voucher values. So we're going to use the UUID application over here to take a look at the voucher values. Let me get one of them. So in here, yeah, let me full screen this. It's so hard to look at. Okay, so over here we've got our vouchers, and the vouchers are used for gifts in the application. I'm just going to grab one of the voucher values, and then we're going to plug it into the UUID identifier website. Okay, so if you suspect that something is a UUID, you could use a tool like this to get some information from it. So we're just going to click on decode UUID. And this tells us that this UUID is UUID version 1, and it also indicates a time. So the contents are a time, which is a date stamp like this. So for example, 2025, October 8th, I think this is, and this is 8 o'clock, 8:56. Okay, so if we see that UUID was used to create these values for the vouchers, we could potentially identify other valid values for vouchers, and this could be used to defraud the website. Basically, redeem vouchers in the system by using the IDOR attack. Okay. So while these look completely random, we can see that UUID version 1 was used. The issue with UUID 1 is that if we know the exact date when the code is generated, we can recover the UUID. So for example, suppose we know that the elves always generated vouchers between 8 o'clock and 9 o'clock. In that case, we can create UUIDs for that entire time period, which we could use in a brute force attack to aim to recover a valid voucher and get more gifts. So now that we've seen the various IDORs that can be found, let's discuss how to fix them and avoid them. Improve design, obliterate risk. So now that we've learned what an IDOR is, let's discuss how to fix it. The best way to stop IDOR is to make sure that the server checks who is asking for the data every time. It is not enough to hide or change the ID number. The system must confirm that the logged in user is authorized to see or change that information. Don't rely on tricks like base64 hashing the IDs. These can still be guessed or decoded. Instead, keep all the real permission checks on the server. When a request comes in, check, does this user own or have permission to view this item? Use random or hard to guess IDs for public links, but remember that random IDs alone don't make your app safe. Always test your app by trying to open another user's data and making sure it's blocked. Finally, record and monitor failed access attempts, as they can be early signs of somebody trying to abuse an IDOR. So, okay, let's answer the questions. So most of these questions are pretty easy. In this case, what does IDOR stand for? IDOR is Insecure Direct Object Reference. Okay. And which type of privilege escalations are most IDOR cases? And most of the time when you're using an IDOR attack, you're accessing somebody else's data, which is on the same level as you. So regular users, that's an example of horizontal privilege escalation. Horizontal. Okay. So using the IDOR found in the view accounts parameter, what is the user ID of the parent that has 10 children? So we actually need to do an IDOR attack now. We'll go back to here and we'll take a look at the cookies. So we're just going to go over to our web developer tools and we're going to go over to our cookies in our storage. So storage, local storage. Oh, I'm not looking at the right storage. Okay, we'll click into here. We'll do F11. Sorry, the keyboard shortcut is Control-Shift-I. Okay, we go over to storage, local storage, and then we change our user ID. So to change the user ID, we can take a look at all sorts of users. We can take a look at user number 14, reload the page, and we see we get a user named Pickle Rick with some children. We're looking for a user that has 10 children. So let's go back in. And the answer is actually user number 15. If you do a lot of scrounging around. Okay, reload the page. And this user is named Sir Breeds a Lot. Sir Breeds a Lot at 10children.thm. But anyways, this is the user with 10 children. I guess the name kind of fits. And this is the user ID. So the user ID is number 15. So this is user 15. Okay, so we got a couple of bonus tasks. We'll do them just for fun. If you want to dive even deeper, use either the base64 MD5 child endpoint and try to find the ID number of the child born on 2019 April 17th. So we don't actually need to do an IDOR attack to do this because the answer is on this page right here for user number 15. So it is 2019-04-17, and it's this user, this child right here named Willow. So we're looking for, what are they looking for? Try to find the ID number of the child. Okay, so the ID number of the child. Click on View Details. So let's see. Child ID 19, so that's the question. That's the answer here. I mean, I guess we could also look in the network tab here when we reload the page. Why does it look so bad? Okay, and we could click on any of these children. Say we click on Poppy, and then we see this one over here for this child. Response, Poppy child ID 16, and we would go through this as an IDOR, but instead of this file, we would have to base64 encode all those numbers. So yeah, the answer is 19. Okay, let's go back. Okay, so all we need to do now is click on the checkboxes over here, and then we're finished. All right, everybody, this was a guided walkthrough for day number 5 of the TryHackMe Advent of Cyber event for 2025. IDOR, Santa's little IDOR. Everybody, if you liked this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs, out.